So welcome to this latest video 162 Maths, and in this video we'll be continuing the series of going through some big mock questions taken from some past GCSE Maths higher exam papers. Now before we get started working through some of these questions, a little reminder that a copy of the questions is available for you to download by clicking the link in the description, and I strongly recommend you have a attempt at these questions before watching these videos. We go through the answers just so you can see how you would have fared without any assistance. And I'll also include a link to the 162 Maths contents page, which gives you easy access to learning or going through lessons on all of the GCSE topics in greater detail, and there's also links that gives you easy access to the GCSE Maths audits and also past exam paper walkthroughs. So let's get started on question 1. So question 1 says 100 people were asked about the distance they travel from home to work. The table shows the information about the results, and question A is asking us to write down the greatest possible number of people who work from home. So for this, all we need to do is we know that there are 100 people, and the greatest number who work from home is going to be, imagining that the first column, they're all 0, because obviously if you travel from home, you're not actually travelling. So the greatest number here is going to be 21. Then for B, it says one person is chosen at random. Work out the possibility, or probability I should say, that the person travels at least 10 miles. Well, at least 10 miles is going to be adding up these two columns here. So it's these two rows, I should say. So it's going to be 37 plus 18, which is 55, which gives us a probability of either writing 55 over 100, or we can simplify that as 11 over 20. So any of those fractions will be good enough for the 1 mark. Then for question C, it says a table is repeated. Draw a histogram to represent the results. So for this, what we need to do is we need to create a midpoint column. No, we don't need a class width column. Getting a bit confused myself. So the class width is basically the size of the difference between the upper bound and the lower bound. So for the first one it's 5, second one's 5, third one is 10, and the fourth one is 20. Then from this we can use the formula of that frequency density equals the frequency divided by the class width. So here the frequency density is going to be 21 divided by 5, and then if I just write divided by each of these, we get values of frequency density being 4.2, 4.8, 3.7 and 0.9. And then all that's left for me to then do is to plot the distances using the class widths or the boundaries and the frequency density, and what you should end up with is something that looks like this, remembering to make sure that the bars are the correct width and the correct height. Moving on to question 2, it says that a solid trophy consists of a stand and a player. The stand is made by removing the small pyramid from the large pyramid, and we've got our calculation here, and it gives us a formula for a pyramid. And the question for part A is to show that the volume of the stand is 258 cubic centimeters. Now the volume of the stand is equal to the volume of the big pyramid minus the volume of the small pyramid. So what we need to use the data that we've been given here and substitute that into this formula that's been given. So for the big pyramid, it's going to be a third multiplied by the base area, which is got edge of 6, so it's going to be 8 squared, multiplied by 16, which gives me a value of 1024 divided by 3. Then for the small pyramid, it's going to be using the same formula. This time the square base is going to be 5 squared multiplied by the height, which is 10. And if I substitute that into my calculator, I get an answer of 250 divided by 3. So all that's left for me to then do is take away these two numbers together. So the volume of the stand is going to be equal to 1024 divided by 3 minus 250 divided by 3. And again, if you've used the decimal equivalents, that's absolutely fine, but you should have an answer of 258, which is exactly what they wanted me to show. For B, it says the trophy is made from a metal of density 7.5 grams per cubic centimetre. The total mass of the trophy is 234 grams. Work out the volume of the player. So for this we need to use the formula or the triangle that mass over volume equals density. So let me just change that to dV. So it's using this formula. So here we know that the mass is equal to 2340. Now we want the units in grams per cubic centimetre. So they're the units I need to be measuring both my mass and my volume. And we know that the density in the question is 7.5, and I know that the volume is equal to, it's going to be, now the volume for the actual trophy is going to be 2340 divided by the density, which is 7.5, giving me a volume of 312 cubic centimetres. So therefore, to work out the volume of the player, I need to use my answer that I've just got of 312 minus the answer I got in part A, so that's 258, giving me a total volume of 54 cubic centimetres. Moving on to question 3, we've got a column vector. It says A is m over 3, B is, not m over 3, it's m3, B is minus 4p, and the diagram shows a vector of 2a plus b. And the question is asking us to work out the values of m and p. So let me just zoom out so we can see all of that question in all its entirety. So what we've got is we know that 2 lots of A plus B is equal to this column vector, which is, working this out, going across, is going to be 8, 5. Now substituting in the vectors for A and B, we've got 2 lots of M3 plus B, which is minus 4p, and that's equal to 8, 5. So what we then know is we know that 2m and 6 plus minus 4 and p is equal to 8 and 5. Now what we know when using vectors is the calculations at the top must equal the same and the bottom must equal the same. So what I should have is two equations of 2m minus 4 equals 8, in which m is going to equal 8 plus 4, which is 12, divided by 2, which is 6. And I also know 6 plus p equals 5, so therefore p equals minus 1, and there is my values for p and m. Moving on to question 4, which says that PQ is the diameter of a circle and QR is the tangent to the circle. Work out the radius of the circle. And we know that PQ is equal to QR and PR equals 10 centimetres. So let's have a look at what we know. So we know that we've got an isosceles triangle. We also know that this angle here is going to be a right angle because the radius of and a tangent meet at 90 degrees. We know that this is 10. So if I call this x and this x, then what we know is we can then use Pythagoras to work out what x is. So what we know is that x squared plus x squared equals 10 squared. So 2x squared equals 100. So x squared equals 50. So x equals root 50. So that means that there is the diameter of the circle. So therefore the radius is going to be equal to root 50 over 2, which if I substitute into my calculator because it wants the answer as a decimal, I get an answer of 3.5355. And so, yeah, if you want to round your answer up, so I'm going to write my answer to 3.5 centimetres to 1 decimal place. And I'll write 2 there, so let me just get rid of that. And that's to 1 dp. Moving on to question 5, it says simplify 2, and then we've got x plus 4 to the power of 5 over x plus 4 to the power of 3. So let's just write this out first. Now, hoping that you're not going to expand the brackets because that's going to take you a fair while, we can see we've got a common factor from both the numerator and the denominator. So as you can see, we've got brackets, so I can take the lowest power from both. So I can take 3 from the 5, so that leaves me with 2. And that leaves me with 2 lots of x plus 4 squared. Now that is the same as 2 lots of x plus 4 multiplied by x plus 4, which gives me 2 lots of x squared plus 8x plus 16. So all that's left for me to then do is multiply out the 2, which leaves me with 2x squared plus 16x plus 32, which is exactly the form that they want my answer left in. Moving on to question 6, it says AC is the diameter of a circle with centre E. E is the midpoint of BD. Prove that the triangle ABE is congruent to the triangle CDE. And so for this, what we need to prove is we need to prove that either two sides and an angle are the same, an angle and a side and another angle are the same, or that 3 sides are the same, or that we've got a right angle triangle. So looking at the diagram, what I know is, let's just first of all highlight the 2 triangles. So this is one triangle, and this is the other triangle. Now, in terms of this, what we know is that this angle is going to be equal to this angle. So angle AEB is equal to CED. And the reason for that is because they are opposite angles. And there we've proved that an angle is the same. Then we need to prove that a side is the same. So we know that CE is equal to AE. And that is because they're both the radius of the circle. So there we've proved a side is the same. Then all that's left for us to prove it either to show that another angle is the same or another side the same. Well, if E is the midpoint of BD, then BE is going to be equal to ED. So that proves another side is the same. So therefore, as we have SAS, triangle ABE is congruent to triangle CDE. And there we go.